Hello students, this video will help us go through information we need for the third lab assignment. We're going to do that by looking at lab number 3 exercise or practice in order to prepare us to do the lab assignment. So the lab exercise is based on binomial practice, normal distribution practice, and at the very end a practice for approximating binomials by using normal distribution. So we're first going to go to our normal distribution or binomial practice tab. It says to enter a value of 0.65 for the probability and a value of 8 for n. Because n is 8, x could be any value from 0, any whole number, from 0 up to 8. Within the lab assignment or lab exercise, it asks us to calculate the binomial probability when there are 3 successes out of 8 trials, with the probability of success being 0.65. So we can do that by using a binomial distribution function where it asks for the values of x, comma n, comma p, and then at the very end we put false. So there is our probability of 3 successes, given that there are 8 trials with a probability of success of 0.65. Now, one thing that you shouldn't do using Excel is enter these values that we did for n, x, and p. What we should do is up in here, go in here and replace the value. So we'd have click on the x value for 3, click on the n value, click on the probability of success, and at the very end typing in false as part of the Excel's function, and we get that same probability. The benefit of using the values as already listed in the cells is that if we copy this down, it will allow us to enter the formula once and get the probability for various x values. One thing we need to work on or understand before that is if we copy this formula down, it's going to change from B7 to B8, which is great because x is now 4, but it'll also change the values for B2 and B1. Anything in yellow here, we want to have that cell location fixed. In order to do so, we would go up to that formula bar, highlight B2 and B1 at the same time, and we're going to make those cells have an absolute cell reference. We can go into that, we can click type or press F4 to do so, or you need to insert the dollar signs. I have 2 dollar signs in there, which is a little bit of overkill. All we would need is a dollar sign between the B and the 2 and the B and the 1. So we click on that and we drag this down, and then copy it up here. We have the distribution for the probability of each of those x values. One thing we should make sure is that they all add up to 1. So these are all possible outcomes for 8 trials with the probabilities associated with each one of those, and they add up to 1. So remember to use the binom dist function as we have explained there, as explained in the lab exercise. Moving on to the normal distribution. This is a set of data. We're going to calculate the average using the average function. We're going to highlight all of our data. We're going to do the same thing for standard deviation. Standard deviation, one with a p at the end, and we're going to highlight all of our data. So our average is 224 and our standard deviation is about 21.8. One thing we want to calculate is our z values. We know how to calculate z values on paper. It's x minus the average and then all divided by the standard deviation. So we're going to do the same thing here. Instead of typing in 255, we're going to click on this value for 255, click on the value that corresponds to the average, divided by the value that corresponds, or the cell location that corresponds to the standard deviation. And we get this, a few decimal places. We know that, at least in our normal distribution chart, Z values are going to be only for 2 decimal places. So let's now insert a round function to restrict it down to 2 decimal places. So it's going to be equals round bracket and then whatever you had in the formula for a Z value, and then comma 2 and close your bracket. And now it's 1.42, so if we increase the decimal places, it's nothing after the 2. So it's restricted it to only 2 decimal places. Now if we were to copy this down, we could find the Z values for each and every one of these X values. However, keep in mind that when we copy it down, it's going to change from B2 to B3, which is great, but it's also going to change the cell location for the mean and standard deviation. We want basically these values in green to be held to be fixed, to have an absolute cell reference. So we're going to change that to that, put some dollar signs in there to make those cells absolute. Relative cell reference would, or mixed cell reference would work as well, as long as you have the dollar sign before the number. So H $4 and then H $5. I keep 2 only because when you do the F4 function on your computer, that's the first one that comes up, and basically that is sufficient for what we need. So looking at your Z values, you'll know that some Z values are positive, some Z values are negative. A negative Z value only means that it's less than average. It's on the left side of that distribution. What we want to do next is find the area. We know how to find area by looking at the normal distribution chart as part of our course package. We have the Z value to do it to 2 decimal places. We can find area. I would recommend finding area for at least one of those Z values, jotting it down somewhere so that when we find the area for using Excel function, we would know that it's the correct one. So the function we're going to use is norms dist. Keep in mind that there's no periods in that, it's all one word, and there's an S in the middle. Excel has a few other normal distribution functions. This is the one we're going to be using. And that is what we have to enter, just as explained in the lab exercise. We need to subtract a value of 0.5 at the end, only because Excel finds the area under the curve, under the normal distribution curve, a little different than the process we're using in our course. Our course package, normal distribution chart, finds the area from the middle of the distribution to the Z value, whereas Excel finds it from the very, very far left of the distribution to the actual Z value. So if we want this area to correspond to the area we get in our normal distribution chart, we need to subtract a value of 0.5. Now if we were to copy this down, we would get values, we would get those values corresponding to the appropriate Z value. This Z value, however, is the area is negative. We don't want a negative area. It's only negative, as I said, because Excel finds areas slightly different. In order to change that, there's a minor calculation we would have to do to change that, or what I would recommend when you're finding an area for a variety of Z values is making your Z value positive by putting in an absolute function right around that Z value in that normal distribution function. So it would look like that. It'll be, let's do it for the other ones as well. So it's going to be norms dist bracket ABS. ABS is the absolute cell function. Bracket C2, which is our Z value, a couple brackets, and then subtract 0.5. So all we've done is inserted the absolute function for the Z value. So the area is going to find, the function is going to find area for positive Z values. And if we were going to, if we copy this down, those are the area corresponding to the appropriate Z values. So in this one, the key function to use is norms dist, with an absolute function embedded as well around for the around the C2 value, the Z value. Last little bit is approximating a binomial by using normal distribution. This question sets up as a binomial. We can calculate the average of a binomial by clicking on the value for n times in the value for p. Same thing for standard deviation. It's a square root sqrt function of n times p times in brackets 1 minus p. Oops. So our standard deviation is about 12.8. The question states, asks us to calculate the probability that there are 220 or more, given that the average is 216. So I'm going to quickly draw this out. Let's go here. There's our normal distribution. It has an average of 216. We want the probability that it is 220 or more. Now keep in mind that whenever we convert from a binomial to a normal distribution, there is a little adjustment area that we have to add. The shaded in area increases by a little margin, which then changes the x value. The original x value is 220. The new x value is going to be 220 minus 0.5. So it's going to be 219.5 based on that spot right about there. So in order to calculate the Z value, we're going to go x, which is 220. We're going to subtract 0.5 to get 219.5, and then we're going to subtract our mean divided by our standard deviation. We're going to have a round function over all of that. So it's going to round to 2 decimal places. We're going to apply our normal distribution function for that. Norms dist of our Z value, subtract 0.5. We get this value for an area. And then our answer is going to be 0.5 subtracted. Oops. Sorry. Let's do that. Then let's go 0.5 minus, can't type right now, 0.5 minus that value. So there is our answer, 0.3936. There's a 39.36% chance that the probability that is greater than 220.